Hello, in this lecture we will find out the length of line segment X using two different methods. In the drawing we have quadrilateral ABCD. We know that side DC of the quadrilateral ABCD equals to 6 units, side AD equals to 3 units, and angle ADC equals to 90 degrees. Angle DCB equals to theta, and angle ABC is also equal to theta, and side AB equals to 5 units. And we want to find out the size or the length of line segment BC that is equal to X. So we start with the first method. In the first method we will do a construction. We will extend side AB and side CD by a straight line until they touch each other, until they intersect with each other. So this point is the intersection point or the touching point between extended side AB and extended side CD. We define the touching point between the two sides as point E. Here, I'll repeat again. This point is the touching point between extended side AB and extended side CD, and we define the touching point between the two sides as point E. Okay, so here we have a triangle EBC as two equal angles, and we have a rule that in front of equal angles inside the triangle there are equal sides. So in triangle EBC we know that this angle EBC equals to theta. In front of this angle we have side EC. In front of this angle that is also equal to theta we have side EB. So according to the rule that I mentioned, I will write down the rule. According to rule number 1, in front of equal angles in the triangle there are equal sides. So I will read rule number 1 again. According to rule number 1, in front of equal angles in the triangle there are equal sides. That is to say, in this triangle EBC, angle EBC equals to angle ECB. I'll write it down. In triangle EBC, the big triangle, it is given us in the question that angle EBC, this angle, is equal to this angle. This is actually angle ECB. I will repeat again, triangle EBC. It is given as the question that angle EBC equals to angle ECB. Both angles are equal to theta. So, in front those equal angles, according to rule number 1, there are equal sides. That is to say, side EB equals to side EC. Here, side EB equals to side EC. Okay? According to rule number 1, side EB equals to side EC. Okay? But what is the size of side EB? Side EB equals to 5 plus AE. Side EB equals to 5 plus AE. While side EC equals to 6 plus ED. Okay, we'll subtract 5 from this equation and we'll get that AE equals to 6 minus 5 is 1 plus ED. Okay, here we'll define ED as A. So ED equals to A according to our definition. So here AE will be equal to 1 plus ED, that is A, so we'll substitute ED by A. So according to this equation, AE equals to 1 plus A. So to write down here that AE equals to 1 plus A, and actually we extended CD is one side of quadrilateral ABCD, and if, as a side of a quadrilateral, it is absolutely a straight line. Okay, CD is a straight line, and then we extended the straight line CD by a straight line, and the result is CE. The result is CE. So when you extend a straight line by a straight line, the result must be still a straight line. So EC is a straight line. I can write down that side EC is a straight line. Actually, EC, it is also one side of triangle EBC, therefore it is absolutely a straight line. Anyway, EC is a straight line. So you can write down that EC is a straight line. Line segment EC is a straight line. I repeat again, EC is one side of triangle EBC, and also when you extend the straight line CD by straight line, the result is straight line. So EC, it is absolutely a straight line. And then we have rule number 2, that the sum of the angles on one side of a straight line is equal to 180 degrees. The sum of the angles on one side of a straight line is equal to 180 degrees. So I will read rule number 2 again. According to rule number 2, the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that EC is a straight line, so if we focus on this side of the straight line EC at point D, then on this side of EC at point D, the sum of the angles must be equal to 180 degrees according to rule number 2. So at point D, at this side of point D, the sum of the angles must be equal to 180 degrees. So which angles we have at point D? At this side of point D, we have here 90 degrees plus angle EDA or ADE, plus angle ADE. In total, the sum of those two angles must be equal to 180 degrees according to rule number 2. This rule. So I will subtract 90 degrees from this equation, and we get that angle ADE, the missing angle, is equal to 180 degrees minus 90 degrees, it is 90 degrees. So the missing angle equals to 90 degrees. This angle ADE equals to 90 degrees. So if angle ADE equals to 90 degrees, it means that triangle ADE is a right triangle. So we will implement the Pythagoras theorem on the right triangle ADE. In the right triangle, triangle ADE, by PT is the equation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, here AE squared, that is the square of the hypotenuse, equals to AD squared plus ED squared. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. It means that AE squared equals to AD squared plus ED squared. AE squared, it is equal to 1 plus A squared. 1 plus A squared. And it is equal to AD squared. AD is 3, so AD squared is 9. Because it is 3 squared, it is 9. Plus ED squared. ED equals to A, so ED squared equals to A squared. Here we will open the brackets on this side of equation number 1. And we'll get that according to equation number 1, one plus A squared, it is equal to 1 plus A squared plus 2A. And in the other side of equation number 1 we have 9 plus A squared. Here in equation number 1 we have a on both sides, a square on both sides of equation number 1, so a square will get cancelled. We will subtract 1 from this equation number 1, and we will get that 1 minus 1 is 0. So here we left only with 2a, that is equal to 9 minus 1, that is 8. So in conclusion, we found out that 2a equals to 8. Here we divide this equation number 1 by 2, and we get that a equals to 8 over 2, that is 4. So we found out that a equals to 4, so here a equals to 4. So a plus 1 will be equal to 4 plus 1, that is 5. So in the next step we will define angle BEC. This angle is angle alpha. So in the right triangle AED, this right triangle, cosine alpha equals to ED over AE. Cosine alpha equals to ED over AE. ED equals to 4, AE equals to 5. So in conclusion, found out that cosine alpha equals to 4 over 5. We will implement the law of cosines in the big triangle that is actually isosceles triangle ABC. I repeat on the law of cosines that is true in any triangle. If we have a triangle ABC, that could be any triangle. The length of side AB is A, the length of side AC is B, and the length of side BC is C. This is angle theta or alpha. So here, this is the law of cosines that is true in any triangle. Here C square equals to A square plus B square minus 2 times AB times cosine alpha. So actually cosine alpha here, cosine alpha will be equal to A square plus B square over 2AB. If we add to this equation 2AB cosine alpha, so 2AB cosine alpha will be here, then we'll subtract C square. Here it will be A square plus B square minus C square, and this in this side of the equation we will have 2 times AB cosine alpha, then when we divide this equation by 2 times AB, we get that cosine alpha equals to A squared plus B squared minus C squared over 2 times AB. So we can implement the law of cosines in our triangle. So according to the law of cosines, in our triangle EBC, cosine alpha, according to the equation here, cosine alpha equals to A squared plus B squared minus C squared over 2AB. That is to say, cosine alpha here in this triangle EBC will be equal to BE squared plus EC squared minus X squared over 2 times AEB times EC. I repeat again, in the associated triangle EBC, according to the law of cosines, we get that cosine alpha equals to BE squared plus E squared minus X squared over 2 times EB times EC. We have already found out that cosine alpha equals to 4 over 5. Cosine alpha equals to 4 over 5, so we can substitute cosine alpha in this equation by 4 over 5. And here EB equals to 5 plus 5, that is 10. And EC is also equals to 4 plus 6, that is also 10. So we know that EB equals to EC equals to 10 units. So here we get that cosine alpha, it is equal to 4 over 5 equals to BE squared. BE is 10, so BE squared is 10 squared, that is 100, plus EC squared. EC is equals to 10, so EC squared is 10 squared, that is 100. Minus X squared is the missing variable, we leave it as it is, over 2 times EB, that is 10, times EC, that is also 10. So 10 times 10 is 100, and 100 times 2 is 200. So here we will multiply this equation by 200, and we get that 4 over 5 times 200 equals to 100 plus 100 minus x squared. Here 4 over 5 times 200, 200 over 5 is 40, and 40 times 40 is 160. So 160 equals to 100 plus 100 is 200 minus x squared. So we'll add x squared to this equation, and we get that x squared equals to 200, and we will subtract 160 from this equation, minus 160. So x squared equals to 200 minus 160 is 40. We take a root out of this equation, and we get that x equals to the square root of 40. The square root of 40 is 4 times 10. 4 times 10, and the square root of 4 is 2, so it is 2 times square root of 10. So in conclusion, we found out that x equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, so we finished with the first method. The length of line segment x that is equals to BC, it is equals to either 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. The length of this line segment x equals to either square root of 2 times square root of 10, or in terms of numbers, it is equal to 6.32 units. Okay, we finished with the first method. In the next step, I will present to you how to find out the length of side BC that is actually equals to x according to the second method. In the second method, we do another construction. From point A, we draw a straight line on DC in such a way that it will be perpendicular to BC. We define the touching point on the straight line from point A and DC as point E. So we drew the straight line AE in such a way that AE is parallel to BC. According to our construction, AE is parallel to BC. In the next step, from point E, we draw a straight line on BC in such a way that the straight line will be parallel to AB. We define the touching point of the straight line from point E and BC as F. So we draw the straight line in such a way that EF is parallel to AB. Actually, quadrilateral AEBF is a parallelogram. Okay, actually we created quadrilateral AEBF that is a parallelogram. Okay, so I'll write it down. Quadrilateral AEBF is a parallelogram. That is to say, it is a quadrilateral that has two couple of sides that are parallel to each other. Here AB is parallel to EF, and AE is also parallel to BF. Okay? and the angle ABC, this angle that is equal to theta, must be equal to angle EFC. That is to say, this angle must be also equal to theta, according to rule number 3, that the corresponding angles between parallel lines are equal to each other. Okay, so we have rule number 3. It says that corresponding angles between parallel lines are equal to each other. I'll repeat again on rule number 3, according to rule number 3, corresponding angles between parallel lines are equal to each other. So if, according to our construction, AB is parallel to EF. I'll repeat again. AB is parallel to EF according to our construction. Those two angles are defined as corresponding angles, and they are located between the parallel lines AB and EF. Therefore, according to rule number 1, they are equal to each other. That is to say, angle ABC, this angle, equals to this angle. This is actually angle EFC. So according to rule number 1, angle ABC equals to angle EFC. Rule number 1. Rule number 4. Rule number 3. Rule number 3. According to rule number 3, angle ABC equals to angle EFC because those two angles are corresponding angles and are located between the parallel lines AB and EF, therefore they are equal to each other. But it is given as the equation that angle ABC equals to theta. Here we know that angle ABC equals to theta according to what is given as the equation. So from this equation, theta equals to ABC equals to angle EFC, we will derive that angle EFC is also equals to theta. So this angle EFC equals to theta. Okay? Likewise, according to rule number 1, because of the fact that AE is parallel to BC according to our construction, side AE is parallel to side BC according to our construction, so AE is parallel to BC. According to rule number 3, those two angles are defined as corresponding angles and they are equal to each other. Why? Because they are located between the parallel lines AE and BC. So we can write down that this angle, that is actually angle DCB, angle DCB is equal to this angle that is actually angle AED. I'll repeat again. Angle DCB equals to angle AED. They are equal to each other according to rule number 1. Why? Because they are defined as corresponding angles and they are located between the parallel lines AE and BC, therefore they are equal to each other. That is to say, angle DC equals to angle AED according to rule number 1. But it is given us the question that this angle DCB equals to theta. So we can write down here that angle DCB equals to theta. And from this equation, theta equals to DCB equals to AED, we will derive that angle AED is also equals to theta. So this angle equals to theta according to rule number 1, rule number 3 of course. And here we know that it is actually DC is equal to 6 units. So actually it is better to so DC it is equals to 6 units according to what is given as the question, okay? And here we know that in a parallelogram AB is equals to EF. AB is parallel to EF, therefore we know that the opposite sides of a parallelogram are equal to each other. This will be rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. Alright, rule number 4 again. According to rule number 4, the opposite sides of a parallelogram are equal to each other. That is to say, the opposite sides of a parallelogram AEBF are equal to each other. It means that AB equals to EF. According to rule number 4, AB must be equal to EF. AB equals to EF. According to rule number 4, that the opposite sides of a parallelogram are equal to each other. But AB equals to 5 units according to what is given as the question. So we can write here that AB equals to 5 units. And from this equation 5 equals to AB equals to EF, we will derive that EF is also equals to 5 units. EF is also equals to 5 units, so we can write here that here EF equals to 5 units. Okay. And we have already the triangle EFC, in triangle EFC, this triangle, in triangle EFC, we have two equal angles. Those two angles, they are equal to each other. They are both equal to theta. So angle EFC is equal to this angle, angle ECF. And both angles are equal to theta. So in triangle EFC, know that the angle EFC equals to angle FCE equals to theta, both angles are equal to theta. And we have the rule number 1 that I mentioned in the first method, that in front of equal sides in the triangle there are equal, in front of equal angles in the triangle there are equal sides. That is to say, EC will be equal to EF. Those two angles are equal to each other, therefore EC must be equal to EF. EC in the right triangle, in triangle EFC, EC must be equal to EF. But EF equals to 5 units. Found out that EF equals to 5 units. So from this equation, EC equals to EF equals to 5, we will derive that EC is also equals to 5. EC equals to 5. So we can write down here that EC equals to 5. So we know that DC equals to 6 units. EC equals to 5 units. So what is the size of DE? It is very simple. DC minus DE equals to DE. DC minus DE equals to DE. I repeat again, DC minus EC, DC minus EC equals to DE. DC equals to 6 units. We just right now found out that EC equals to 5 units. So DE equals to 6 minus 5, that is 1. DE equals to 1 unit. Can write down here that DE equals to 1 unit. Okay, I'll repeat again. DC minus EC equals to DE. DC equals to 6 units, EC equals to 5 units, so DE equals to 6 minus 5, that is 1. So we'll focus on the right small triangle, triangle AED. In the right small triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. By PT is the equation for Pythagoras theorem. The hypotenuse in the right triangle ADE is AE, so AE squared equals to the sum of the squares of the perpendiculars, equals to AD squared plus DE squared. I repeat again, in the right small triangle, triangle AEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say, AE square equals to AD square plus DE square. Okay? So AE square equals to AD square. AD equals to 3, so AD square is 3 squared, that is 9, plus DE square. We just right now found out that D equals to 1, so 1 square is 1. In conclusion, we found out that according to equation number 1, AE square equals to 9 plus 1. 9 plus 1 is 10, that is to say AE square equals to 10. Here we take a root out of this equation, equation number 1, and we get that AE, according to equation number 1, equals to the square root of 10 units. So we can write down that AE equals to the square root of 10 units. And according to the rule that the opposite sides of a parallelogram are equal to each other, we will get that AE equals to BF. In parallelogram AEBF, the opposite sides are equal to each other. That is to say, AE equals to BF. Here appears information for parallelogram. So in parallelogram AEBF, we know that AE must be equal to BF. AE must be equal to BF according to rule number 4, that the opposite sides of a parallelogram are equal to each other. But we just right now found out that A equals to square root of 10 units. Here A equals to square root of 2 units, and from this equation we will derive that BF is also equals to square root of 10 units. So we can write here that BF equals to square root of 10 units, but according to what is given us in the question, BC equals to X. BC equals to X. BF equals to square root of 10. So here FC, it is very easy to see from the drawing that FC equals to BC minus BF. Okay, from the drawing it is very easy to see that FC equals to BC minus BF. So FC equals to BC, that is X, minus BF, that is square root of 10. In conclusion, found out that FC equals to X minus square root of 10 units. So we can write here that FC equals to X minus square root of 10 units. In the next step, from point E, we'll focus on the isosceles triangle EFC. From point E, that is the vertex of the isosceles triangle, we will draw perpendicular on FC. From point E, we will draw perpendicular on FC. So this angle equals 90 degrees according to our construction, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point E and FC as M. And we have also rule number 5. According to rule number 5, the height to the base in an isosceles triangle bisects the base. I write it down. The height to the base in an isosceles triangle bisect the base. We'll read rule number 5 again. According to rule number 5, the height to the base in an isosceles triangle bisects the base. So here, according to rule number 5, we know that triangle FEC is an isosceles triangle because of the fact those two sides are equal to each other. They are both equal to 5 units. So in triangle EFC is an isosceles triangle. The isosceles triangle EFC, the height EM to the base FC, the height EM to the base FC bisects the base FC. That is to say, FM equals to MC. FM equals to MC. FM equals to MC. According to rule number 5, FM equals to MC, and actually it is equal to FC over 2 also. Okay, it is equal to FC over 2 because of the fact that according to rule number 5, the height EM divides the base FC into 2 equal parts. That is to say, FC over 2 will be equal to MC, will be equal also to FM. So FC over 2 equals to FM equals to MC. But we have already found out that FC equals to x minus square root of 2. Therefore, MC will be half of it. It is FC over 2. So MC will be equal to, here it is x minus square root of 2, x minus square root of 10 over 2. Because it is FC over 2. FC over 2 is x minus square root of 10 over 2. So here we know that MC equals to x minus square root of 10 over 2. This is the value of side MC. Okay. In the next step, we will prove that the right triangle ADE is similar to the right triangle EMC. Okay, we will prove that those two right triangles are similar to each other. So maybe I will print them in the green color and prove that the right rectangle triangle ADE is similar to the right green triangle EMC. So why those two right green triangles are similar to each other? First of all, angle ADE, this angle, angle ADE, this angle is equal to this angle that is actually angle EMC, and both angles are equal to 90 degrees. I'll repeat again. We'll prove that the right green triangle ADE is similar to the right green triangle EFC. Why they are similar to each other? First of all, angle ADE equals to angle EMC equals to 90 degrees. But here in the right triangle EDE, because of the fact that this angle equals to 90 degrees, this angle equal to theta, this angle must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this right triangle AD 280 degrees, this angle must be equal to 90 degrees minus theta. Likewise, from the same reason, in the right green triangle triangle EMC, this angle equals to 90 degrees, this angle equal to theta, so this angle must be equal to 90 degrees minus theta. Okay? So, in addition, angle DEA or angle AED here, angle AED is equal to this angle that is actually angle ECM, and both angles are equal to theta. Okay, I'll repeat again, angle AED equals to angle ECM, and both angles are equal to theta. Finally, this angle that is actually angle DAE is equal to this angle that is actually angle MEC, and both angles are equal to 90 degrees minus theta. Okay, I'll repeat again, angle DAE is equal to angle MEC, and both angles are equal to 90 degrees minus theta, so we prove that all the angles of the right green triangle ADE can go into all the angles of the right triangle EMC. Those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. Those two angles are both equal to 90 degrees, therefore they are equal to each other. And those two angles are both equal to theta, therefore they are equal to each other. Therefore, triangle ADE, this right green triangle, is similar to the right green triangle EMC. This is the sign of similar. according to angle similarity rule. And from the fact that the two green triangles, the two green right triangles are similar to each other, we will derive that AE over EC is equal to DE over MC. And repeat again, from the fact that the two green triangles are similar to each other, we will derive that AE over EC equals to DE over MC. We know that AE equals to square root of 10 units, so we substitute AE by square root of 10 over EC. EC equals to 5 units. We substitute EC by 5. And it is equal to DE, that is 1, so we substitute DE by 1 over MC. MC, according to what we have already found out, equals to x minus square root of 10 over 2. So we substitute MC by x minus square root of 10 over 2. So in conclusion, according to equation number 2, we found out that square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we will move 2 to the numerator and x minus square root of 10 to the numerator, and we will get that according to equation number 2, square root of 10 over 5 equals to 2 over x minus square root of 10. We will cross multiply this equation number 2, and we will get that according to equation number 2, the square root of 10 times x minus square root of 10 equals to 5 times 2 is 10. We divide this equation number 2 by square root of 10. We know that square root of 10 times square root of 10 is 10. So here, what is written here, square root of 10 times square root of 10, that is equal to 10. So here, square root of 10 over square root of 10 is 1. So in this side of equation number 2, we have left only with x minus square root of 10. And in this side of the equation, what is written here is square root of 10 times square root of 10. And square root of 10 times square root of 10 is square root of 10. We will add square root of 10 to this equation number 2. And we will get that according to equation number 2, x equals to 2 times square root of 10, that is actually 6.32 units. Okay? So, side BC, that is actually equals to x. This side is equals to either 2 times square root of 10 units, so in terms of numbers, it is equals to 6.32 units. Okay? We finished with the second method. In the next step, I will summarize the lecture. So in the drawing we have been given quadrilateral ABCD. We know that side AD equals to 3 units, side AB equals to 5 units, side DC of quadrilateral ABCD equals to 6 units, angle ADC equals to 90 degrees, angle DCB equals to theta, and angle ABC is also equals to theta. And we want to find out the length of side BC that is actually equals to x according to what is given in the question. Okay? So in order to find out the length of side BC that is equal to x, we extended side AB of quadrilateral ABC by a straight line, and we also extended side CD of quadrilateral ABCD by a straight line until they intersect with each other at point E. Point E is the touching point of the extended AB and the extended line segment CD. Again, point E is the touching point of extended side AB and extended side DC. Okay? So, actually, we created here triangle BEC that has two angles that are equal to each other, and therefore it is actually an associated triangle. And we have actually rule number 1. Those two angles that are equal to each other, they are both equal to theta. And according to rule number 1, in front of equal angles in the triangle, there are equal sides. I'll repeat again, in front of equal angles in the triangle, there are equal sides. So, in front of this angle, angle theta, we have side EC. In front of this angle, angle theta, we have side EB. And according to rule number 1, side EB must be equal to side EC. Why? Because those two sides are located in front of equal angles, therefore they also must equal to each other. Why? Because in front of equal angles in the triangle there are equal sides. Okay? Therefore, in the triangle ABC, because of the fact that angle ABC equals to angle ECB and they are both equal to theta, therefore they are equal to each other, we can derive from it that according to rule number 1, side EB must be equal to side EC. Side EB must be equal to side EC. Side EB is equals to 5 plus AE, or EA plus 5 equals to side EB. Side EB equals to 5 plus AE. Side EC equals to ED plus 6. Again, side EC equals to ED plus 6. Side EC equals to 6 plus ED. So here we subtracted 5 from this equation, and we found out that AE equals to 6 plus 5, this is 1 plus ED. So in conclusion, we found out that AE equals to 1 plus ED. Then we defined ED as A. According to our definition, ED equals to A. So if ED equals to A according to our definition, so we will substitute ED by A here, and here we will get that A equals to 1 plus A. So here AE equals to 1 plus A. Okay? So actually, when we extend a straight line by a straight line, it is still must be, the result must be still a straight line, of course, but from the fact that we have already related to triangle EBC, from the fact that EBC is a triangle, EC is one side of triangle EBC, therefore it is absolutely a straight line. But anyway, we extended the straight line CD by a straight line, so the result, that is EC, must be still a straight line. Okay, and in addition, we have already related to figure EBC as a triangle, and side EC is one side of triangle EBC. Therefore, it is absolutely a straight line. Okay, so anyway, EC is a straight line. It is one side of the triangle EBC, and when you extend it, in addition, when you extended the straight line CD by a straight line, the result must be still a straight line. So EC, it is a straight line. Okay, and we have rule number 2 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, according to rule number 2, if you focus on this side of the straight line EC at point D, that the sum of the angles on this side of the straight line EC at point D must be equal to 180 degrees according to rule number 2. Okay, at point D, at this side of the straight line EC, at point D, the sum of the angles must be equal to 180 degrees according to rule number 2. So which angles we have at this side of the straight line EC at point D? We have here 90 degrees, and we have also angle ADE. In total, the sum of those two angles must be equal to 180 degrees. I repeat again. Here, angle, this angle that is equal to 90 degrees plus angle ADE, 90 degrees plus angle ADE, in total they must be equal to 180 degrees according to rule number 2. We subtracted 90 degrees from this equation, and we get that the missing angle ADE, equals to 180 degrees minus 90 degrees, that is 90 degrees. So this is angle ADE that is equal to 90 degrees. This angle is equal to 90 degrees, therefore, that is to say, triangle ADE is the right triangle. So in the right triangle, triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is in front of the right angle, that is to say it is AE. So the square of the hypotenuse is AE square, and it must be equal to the sum of the squares of the perpendiculars, that is to say it must be equal to AD square plus ED square. I repeat again, according to the Pythagoras theorem in the right triangle ADE, AE square must be equal to AD square plus ED square. AE equals to 1 plus A. So we substitute AE by 1 plus A. So AE square, if A equals to 1 plus A, it means that A square equals to 1 plus A square. AD equals to 3, so AD square is 3 squared, that is 9. AD square is 9, and ED equals to A. ED equals to A, so ED square will be equal to A square. So in conclusion, we found out that according to equation number 1, 1 plus A square equals to 9 plus A square. Here we open the brackets on this side of equation number 1, and we found out that 1 plus A square, it is equal to 1 plus A square equals to 1 plus A square plus 2A, and it is equal to 9 plus A square. Here we have A square on both sides of equation number 1, so A square will get cancelled, and we left only with 1 plus 2A, that is 9. We subtracted 1 from this equation, equation number 1, and we got that in this side of the equation, what is left is only 2A, and 9 minus 1 is 8, so in conclusion we found out that 2a equals to 8. We divided this equation number 1 by 2, and we found out that a equals to 8 over 2, that is 4. So here a equals to 4. If a equals to 4, then a plus 1 will be equal to 5. And then, now we actually, in the big triangle ABC, know that side EB equals to 5 plus 5, that is 10, and side EC is equal to 4 plus 6, that is also 10. So it is isosceles triangle, and here we defined angle BEC as alpha, and because of the fact that we know that side EC equals to side EB equals to 10 units, and here we also know the value of cosine alpha, we can use the law of cosines in order to find out x is the only missing variable, because we know that in this right triangle cosine alpha equals to DE over AE. DE is 4, AE is 5, so cosine alpha equals to 4 over 5, and the only missing variable here is x. So we can implement the law of cosines in this big right triangle, triangle ABC. Here, the law of cosines is true in any triangle, so if this is a triangle ABC, that could be any triangle. Side AB equals to A units in its length, side AC equals to B units in its length, and side BC equals to C units in its length, and the angle between side AB and side AC is alpha. Then, according to the law of cosines, C square equals to A square plus B square minus 2 times AB times cosine alpha. Here, if we add to this equation 2AB cosine alpha, we will add to this equation 2AB cosine alpha, and then we will subtract C square. And then we will divide it by 2AB, we will get that cosine alpha equals to A square plus B square minus C square over 2AB. It is very simple to do it, so I did it orally. Okay, so we got that cosine alpha equals to A square plus B square minus C square over 2AB. Okay, so we can implement the law of cosines in our triangle ABC. So according to the law of cosines, we will get that cosine in the right triangle ABC, cosine alpha will be equal to, here we have A square plus B square minus A square plus B square minus C square over 2AB. So it is EB square plus EC square minus X square over 2 times EB times EC. Okay, it is BE square plus EC square minus X square over 2 times EB times EC. This is the implementation of the law of cosines in triangle ABC. We know that EB equals to EC equals to 10 units. So here EB is 10, EC is 10, EBE is 10 squared, it is 100, EC is 10 squared, it is also 100, minus X squared is the only missing variable. Why? Because here cosine alpha in the right triangle AED, in the right small triangle, this right triangle, we know that cosine alpha equals to AD over AE. In this right triangle ADE, we know that cosine alpha equals to AED over EA. Cosine alpha in the right triangle AD equals to ED over AE. ED equals to 4, AE equals to 5. So in conclusion, we found out that cosine alpha in this triangle equals to 4 over 5. Cosine alpha equals to 4 over 5, so we can substitute cosine alpha here by 4 over 5. We did it and we got this equation. Okay? So here 100 plus 100 is 200. So in the numerator we have 200 minus x squared. And in the denominator we have 2 times 10 times 10, that is 200. So we multiply this equation by 200 and we get that 200 times 4 over 5 equals to 100 plus 100 minus x squared. 100 plus 100 is 200. So here we got that according to this equation, we actually found out that here we have 200, here we have 200 over 5 is 40, and 40 times 40 is 160. So in this side of the equation we have 160, and in this side of the equation we have 200 minus x squared. So in conclusion, 160 equals to 200 minus x squared. We subtracted, we added x squared to this equation, and we subtracted 160. And we got that x squared equals to 200 minus 160. 200 minus 160 is 40. So in conclusion, found out that x squared equals to 40. We took a root out of this equation and found out that x equals to square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that the length of line segment x, that is actually also equals to side BC, it is either equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. We finished with the first method. In the next step, I will present to you how we found out the length of line segment x according to the second method. In the second method, we did another construction. Here, from point A, we drew a straight line on CD in such a way that AE will be perpendicular to BC. Again, AE is perpendicular to BC according to our construction. It is very easy to draw a straight line from point A on DC in such a way that it will be perpendicular, that AE will be perpendicular to BC. This is the first construction that we did. In the next step, we also from point E, we drew a straight line on BC in such a way that EF will be perpendicular to AB. Okay, we drew a straight line from point E on BC in such a way that EF will be perpendicular to AB. Okay? Actually, in this way, we created parallelogram AEBC. Any quadrilateral that has two couple of sides that are parallel to each other, it is defined as parallelogram. Here, side AE is parallel to side BC and side AB is parallel to side EF. Therefore, quadrilateral ABC, AEBF is a parallelogram. Okay? So, I'll repeat again. Quadrilateral AEBF is a parallelogram. And we have also rule number 3 that corresponding angles between parallel lines are equal to each other. So here we know that side AB is parallel to side EF. Because of the fact that side AB is parallel to side EF, then those two angles are defined as corresponding angles and are located between the parallel lines A, B, and EF, therefore they are equal to each other. Okay, that is to say angle ABC will be equal to angle EFC. I repeat again. AB is parallel to EF according to our construction. AB is parallel to EF according to our construction. Therefore, according to rule number 3, those two angles are equal to each other. That is to say angle ABC equals to angle EFC according to rule number 3. But it is given as the question that this angle equals to theta. So angle ABC equals to theta. And from this equation, theta equals to ABC equals to EFC, we will derive that angle EFC equals to theta. So this angle equals to theta. Okay? Likewise, according to our construction, AE is parallel to BC. Again, according to our construction, AE is parallel to BC. And if those two angles are defined as corresponding angles that are located between the parallel lines AE and BC, therefore they must be equal to each other according to rule number 3. Okay? Repeat again. AE is parallel to BC according to our construction. Therefore, according to rule number 3, it is actually rule number 3, angle DCB equals to angle DEA. Those two angles are equal to each other. Those two angles are equal to each other because they are defined as corresponding angles that are located between the parallel lines AE and BC, therefore they are equal to each other. So angle BCD equals to angle AED. Okay? But it is given us in the question that angle ECB equals to theta. Okay, angle DCB equals to theta, according to what is given as the question. So from this equation, theta equals to angle DCB equals to angle AED, we derive that angle AED equals to theta. So we derive that this angle is also equal to theta. Okay, then I presented to you rule number 4. According to rule number 4, the opposite sides of a parallelogram are equal to each other. So here, in parallelogram AEBF, the opposite sides are equal to each other. And it means that AB is equal to EF, according to rule number 4. AB is equal to EF according to rule number 4. But AB equals to 5 units according to what is given as the question. So we can write here that AB equals to 5 units. And from this equation, 5 equals to AB equals to EF, we derive that EF is also equals to 5 units. EF is also equals to 5 units. Okay, so then in the right triangle, in triangle EFC, we know that those two angles are equal to each other, they are both equal to theta. And according to the rule that in front of equal angles that are in the triangle there are equal sides, we will get that EF must be equal to EC. Okay? We know that angle EFC equals to angle ECF equals to theta in triangle EFC. Therefore, according to the rule that in front of equal angles in the triangle there are equal sides, we will get that EC must be equal to EF. EC must be equal to EC must be equal to EF. But we already found out that EF equals to 5 units. So we can write down that EF equals to 5 units, and From this equation, AC equals to EF equals to 5, we derive that EC is also equals to 5 units. EC equals to 5 units. So we know that EC equals to 5 units. EC equals to 5 units. DC equals to 6 units. EC equals to 5 units. So what is the value of the small line segment DE? It's very simple. It is DC minus EC. DC minus EC equals to DE. Okay? Here, DC minus EC equals to DE. DC equals to 6 units. EC equals to 5 units. Therefore, the small line segment DE is 6 minus 5, that is 1. So we found out that this line segment DE equals to 1 unit. So in this right triangle ADE, side D equals to 1, side AD equals to 3. So we can implement the Pythagoras theorem in order to find out the hypotenuse. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in the right triangle AED, actually right triangle AED, in the right triangle AED, according to the Pythagoras theorem, we get that AE square equals to AD square plus DE square. Okay? So here AE square equals to AD square. AD equals to 3. So AD square is 3 square, that is 9. Plus DE square. DE equals to 1. So DE square is 1 square, that is 1. So in conclusion, we found out that AE square equals to 9 plus 1, that is 10. AE square equals to 10 according to equation number 1. We took a root out of this equation number 1, and we found out that AE equals to square root of 10 units. This side AE equals to square root of 10 units. But according to the rule that the opposite sides of a parallelogram are equal to each other, we get that AE equals to BF. In parallelogram AE-BF, AE must be equal to BF. According to the rule that the opposite sides of a parallelogram are equal to each other, here, AE must be equal to BF. This is according to rule number 4 that the opposite sides of a parallelogram are equal to each other. But AE equals to square root of 10 units. We just right now found out that A equals to square root of 2 units. Square root of 10 units. A equals to square root of 10 units. And from this equation, square root of 10 units equals to AE equals to BF. We will derive that BF is also equals to square root of 10 units. Okay? Here, BF is also equals to square root of 10 units. Okay, and here, if BF equals to square root of 10 units and BC equals to X, so BC minus BF equals to FC. BC is X and BF is square root of 10. Therefore, FC will be equal to X minus square root of 10 units, okay? Here, FC equals to X minus square root of 10 units. This is BC, that is X, minus BF, that is square root of 10 units. That is to say, BC equals to X minus square root of 10 units. I'll repeat again. FC equals to BC minus BF. So, FC equals to BC, that is X, minus BF, that is square root of 10 units. In conclusion, found out that FC equals to X minus square root of 10 units. This 9 segment FC equals to X minus square root of 10 units. Then I presented to you rule number 5. According to rule number 5, the eye to the base in an isosceles triangle bisect the base. Okay, so here we know that triangle FEC is an isosceles triangle. Why triangle FEC is an isosceles triangle? Because of the fact that side EF equal to side EC equal to 5 units. Any triangle that has two sides that are equal to each other must be at least an isosceles triangle. Because if all of its sides are equal to each other, then it will be equilateral triangle. So because of the fact that EF equals to EC, triangle EFC is an isosceles triangle. So in the isosceles triangle EFC, the height and the base of the isosceles triangle is actually FC. It is of course FC. FC is the base of the isosceles triangle, triangle EFC. Okay? And according to rule number 5, the height EM to the base FC, the height EM to the base EFC bisects the base FC. That is to say, it divides the base FC into two equal parts. That is to say, FM equals to MC. And also FC over 2 equals to MC. Okay? According to rule number 5, we know that a triangle EFC is an isosceles triangle. And according to rule number 5, the height to the base, that is actually EM, bisects the base. That is to say, FM equals to MC, according to rule number 5. And because of the fact that it bisects the base into two equal parts, it means that FC over 2 will be equal to MC, and it also will be equal to FM. So in conclusion, we found out that MC, it is equal to FC over 2. FC equals to x minus square root of 10 units. And if we divide FC by 2, we'll get that MC equals to x minus square root of 2 over 10. Okay? FC over 2 is x minus square root of 10 over 2. That is equal to MC. Okay? So we found out that MC equals to x minus square root of 10 over 2. And then we proved that those two right triangles are similar to each other according to angle similarity rule. So why those two right triangles are similar to each other? First of all, those two angles, they are equal to each other. Why? Because they are both equal to 90 degrees, therefore they are equal to each other. Those two angles, they are both equal to theta, therefore they are equal to each other. And this angle, those two angles, they are equal to each other because they are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the angles in the right triangle ADE can go into all the angles in the right triangle EMC. Therefore, those two green triangles are similar to each other according to angle similarity rule. Okay, I repeat again. We have angle ADE that is equal to angle MEC equals to 90 degrees, angle EAD equals to angle ECM, and they are both equal to theta, therefore they are equal to each other. Angle EAE equals to angle MEC, and they are both equal to 90 degrees minus theta, therefore they are equal to each other. Therefore, the right triangle ADE is similar to the right triangle EMC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that AE over EC, AE over EC equals to DE over MC. Again, AE over EC equals to DE over MC. Okay, going to equation number 2. AE over EC equals to DE over MC. AE equals to square root of 10 units. A equals to square root of 10 units. EC, here we found out that EC equals to x minus square root of 10 over 2. MC equals to x minus square root of 10 over 2. And it is equal to DE. DE equals to 5. Here DE equals to 5. And MC equals to x minus square root of 10 over 2. So we substituted DE equals to 1, of course. So we substituted DE by 1. MC equals to x minus square root of 2 over 10. So we substituted MC by x minus square root of 10 over 2. E equals to square root of 10 units and EC equals to 5. So in conclusion, we found out that according to equation number 2, square root of 10 over 5 equals to 1 over x minus square root of 10 over 2. Here we moved 2 to the numerator and x minus square root of 10 to the denominator, and we found out that square root of 10 over 5 equals to 10 over x minus square root of 10. Here we cross multiply this equation, equation number 2, and we found out that square root of 10 times x minus square root of 10 equals to 10. We divided this equation, equation number 2, by square root of 10. So here square root of 10 will get cancelled and we left only with x minus square root of 10 units. And in this side of equation number 2, 10 is square root of 10 times square root of 10. And square root of 10 times square root of 10 over square root of 10 will give us square root of 10. So in conclusion, we found out that according to equation number 2, x minus square root of 10 equals to square root of 10. We added square root of 10 to this equation, equation number 2, and we found out finally that x equals to either 2 times square root of 10 units, or in terms of numbers, it is equals to 6.32 units. I repeat again, this 9 segment BC, it is equal to x, it is equals to 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay, thank you very much.